everyone, welcome into Unit 12, Day 7 notes, and congratulations, you have made it to the final day of notes. This is it. One more day of notes, then we take our test, and then we have final exams, and then welcome to summer break. But we have one more lesson left, so let's get to it. Jump into it. We are solving by systems of equations by elimination. But this time, let's look at our intention. Students will be able to solve systems of linear equations by method of elimination, multiplying two equations this time. Yesterday, we only had to multiply by one of the equations. We're still including special cases with an 80% accuracy or higher. So let's jump into it. Sometimes when solving systems of linear equations by elimination, you guessed it again, we will have to multiply both equations in order to create a set of opposite variable terms. Just like we wanted to do yesterday, but yesterday we only had to multiply by one of the equations. So just like yesterday, let's take a look at our steps and we will go along with it. So step one, pick a variable you want to eliminate. So if we take a look real quick, always check this first because we're not always going to have to multiply by both variables, but 5x and -2, that doesn't eliminate easily. And then 3y and 2y, that also does not eliminate easily. I noticed that this is already negative and this is already positive. So opposite in terms of their signs, but now we have to make the coefficients themselves opposite. So I'm going to choose the x values to eliminate. So step one's done. I picked which one I want to eliminate. Step two, find a least common multiple for the coefficients. So the least common multiple for 5 and 2 is 10. So we're going to have to multiply the top equation by 2 and the bottom equation by 5. And we will get our opposites. Multiply each equation and add/eliminate. So we have to distribute in for both of them. So that's 2 times 5 is 10x. Then we get 6y equals -24. Now we multiply 5n times -2 is -10x. So we are opposite now. 10y. And we get +40. Now that we have our opposites, let's go ahead and add. Right here are the opposites. They cancel out. We have 6y plus 10y is 16y. And then we add those together and we get +16. Divide by 16. We get y equals 1. So that's step one. Step two, finish solving for the other variable. Again, it does not matter which one we pick. We just need to pick one and plug it in. So 2 times x plus 2 times our y value, which we said is +1, equals 8. So we get -2x plus 2 equals 8. We are going to subtract 2. I'm running out of room, so I'm going to go over to the left here. And we get -2x equals 6. Divided by -2. X equals -3. So our solution, or the lines will cross at the coordinate pair x equals -3, y equals 1. All right, we're going to do two examples together. The other two will be for you all to try on your own. Let's go number 2 first. Skip number 1. You guys will do number 1 on your own. Let's do number 2. So we have a similar situation, 5 and -2. So that's actually just for fun, right? It is actually no, we're going to eliminate the x values again. So this time we notice we have 2 and 5 for our coefficients for x. Now it's a little different because in this situation, neither of them are negative. So we know that 2 and 5 both go into 10, but one of them we multiply by has to be negative. If we kept them both positive, we would end up with +10x for both of them, which would not help us eliminate anything. So one of them has to be negative when we multiply. Again, it does not matter which one. Just need to choose and go. So we have -10x minus 15y, -35. Then we have +10x plus 8y and 28. Let's go ahead and add. That eliminates. We end up with negative 7y, and we end up with negative 7. Divide by negative 7, y equals 1. So now we plug it back in. Does not matter which one. I'm going to choose the top equation. 2 times x plus 3 times our y value, which is 1. We get 2x plus 3. Subtract the 3 from both sides. Divide by 2. X equals 2. So our solution is 2, comma 1. All right, let's go ahead and try example number 3. In this one, let's take a look. Now we have, for our x coefficients, we have negative 2 and positive 3. And we have, for our y values, positive 2 and negative 3. So it's kind of a wash here. It doesn't matter which one we go for. Let's just go ahead and choose our x values. And I need to have a least common multiple for negative 2 and 3, which is going to be 6. So we have to multiply the top by 3 and the bottom by 2. Now always double check that one of those is already negative, which in this case it is, the negative 2. So we don't have to make one of our numbers that we're multiplying in negative. They can both be positive. So we get negative 6x plus 6y equals 9. Positive 6x minus 6y equals 30. Let's go ahead and add. Those cancel. These cancel, so we're left with 0 equals 39. This is not true. So even when we multiply both equations, we can get special cases, which is, in this case, a no solution. All right, take a few minutes, try and do 1, try and do 4, come back, and we'll check the answers. See you in a few minutes. Hey everyone, welcome back. Let's go ahead and check our answers for 1 and 4. For number 1, in this example, we have 2x and 6x and 1y and negative 2y. I decided to eliminate the y values. You could have chosen to eliminate the x values by multiplying by negative 3. I just wanted to eliminate by the y because I knew I wouldn't have to multiply by a negative number, which, again, that's just preference. It doesn't make a difference. But if you see when we multiply in the 2 here, we get a positive 2y, which is going to eliminate with our negative 2y. So that was my train of thought. After I do that, I go ahead and I get x equals 2, plug it back in, y equals 1, and we get a solution of 2, comma 1. This one we only had to multiply one of the equations. So this was just in here to check, are you just multiplying by both equations because that's what we're practicing today, or are you looking at the equation and really making a decision that's going to be the most efficient for your solving? All right, let's check out number 4. So for number 4, we did have to multiply by both equations. And in this case, I chose to eliminate our x values. I know 4 and 3 both go into 12, so I multiply by negative 3 and positive 4. If you did positive 3 and negative 4, that's totally fine. Or if you tried to eliminate the y values, that's totally fine as well. But this is what I went with. So that turns it into negative 12x, positive 12x. As you see, those cancel out. We got 7y equals 35, a y value of 5. Plug it back in. It does not matter which equation you plug it back into. And if you did your math correctly, you get x equals 3. So our solution is 3, comma 5. Whew, there we go. A whole year down. Fantastic job this year, everyone. Good luck on your test and your final exams and your math courses in the future. Please reach out to your teachers if you have any questions. And for the last time, peace out. Have a great rest of your day and a great summer.